Hey guys, last time on 3.1 we talked about increasing and decreasing intervals, right? And I told you guys for increasing interval we will have the slope f of x being greater than 0 or being positive. For decreasing interval we're gonna have the slope being negative, right? And then two more cases when the slope is either like 0 or the slope is undefined or like doesn't exist in here. These two cases in here, we're gonna have the critical numbers or the critical values. Okay? And today, let's talk about extrema and the first derivative test. Alright, so let's review some old concept before we jump into the content of 3.2. We have used the derivative to determine the intervals on which the function is increasing or decreasing, like just what we learned in 3.1. In this section, we will examine the points at which a function changes from increasing to decreasing or vice versa. At such a point, the function has a relative extremum, so it could be a relative maximum or it could be a relative minimum, okay? So let me define like what it means to be a relative maximum and what it means to be a relative minimum, okay? So let f be a function defined as c. For number one, the definition of relative maximum, we have f of c is a relative maximum f if there exists an interval a to b containing c such that f of x, like for all like the values inside that intervals, we always gonna have it less than or equal to f of c for all x in that interval. Okay, so in short, what does it mean, right? So say if you're gonna consider like this interval from here to here, right? So this is your A and this is your B, and then I'm just going like random for this one because I just want to consider this like this quick interval right here to here. Okay, so what happens in here is that, as you can see, like this one in here is the highest point, like right, like in the interval from A to B. This one in here is the highest point among like all the values inside that interval. That's why it's a relative maximum in there, okay? And that's why like all the values in here has to be less than or at least equal to that value of f of c in here. So this is f of c. There we go. And then in another scenario, if we have like, I don't know, like let's say A is from here and then B is from here, right? And then this one, as you can see, is the lowest point, right? So this one is like another f of c where like the f of c in this case will be the lowest value or like the minimum value compared to all the values inside this interval from A to B. Okay, so in short in here, if you know this, let me first take out all these like notation really quick. Okay, if you notice in here, the slope in here is positive, right? Because it's like rising, and the slope on the right hand side of the like maximum in here is negative, right? And then for the minimum in here, the slope in here is negative while the slope in here is positive, right? So that is what it means by the first derivative test. And I'm gonna make it like formal by putting it into like, like a box in the next page, but that's like the concept for the first derivative test. Okay, so occurrences of relative extrema: if f has a relative minimum or a relative maximum when x equal to c, then c is a critical number of f that is either f prime of c is 0 or f prime of c is undefined, right? Like just like how we define the critical numbers in 3.1. okay, so remember one thing, for relative maximum and relative minimum, the x part, the x values, it has to occur when f prime of that x value equal to 0 or undefined. Okay, and now let's talk about the first objective, the first derivative test. Like what I mentioned earlier there, like in short, this table, it just tells you that if you have from like a negative slope to the positive slope in here, then we have a minimum. And if we have from a positive slope to a negative slope, then we have a relative maximum. And the way that we look at it is that we always go from left to right. Okay, so we always go from left to right, like always. Okay, if you can see, like this one is going down for like being negative, and then it goes up for being positive. That's why it's the lowest point, and that's why it's also a minimum. Okay, for the other case, as you can see, this one is positive, that's why it's going up, and then this part in here is going down for being negative. That's why in between we're gonna have a maximum. Okay, And there could be a case when it's neither a maximum or a minimum. So from the last two like examples in here, this point in here, right, like as you can see, like this slope in here is increasing, so it's positive, and then on the right side it's also like increasing, right, so it's also like a positive in here, right, so there's no change in the sign here, in the side of slope in here. That's why it's not like a minimum or a maximum. Okay, or from this scenario, if you want to look at it, like the slope in here is like going down, so it's negative, right, and then it keeps going down further on the right hand side of C. So then this one is neither a maximum or a minimum. Okay, so this is all that like about. Okay, so as long as you remember the shape, like the U shape of it, and the signs of them, like positive for like increasing slope and then negative for decreasing slope in there, then you should be safe. Like if you draw the shape out, then you should be able to define which one is maximum and which one is minimum. Okay, and now let's talk about the first example in here. So find all the relative extrema of the following function. Okay, so for my part, I have that function right there, and a good technique that I show you guys from the 3.1 on how to find like the increasing and decreasing intervals in there was the table of signs, right? So unfortunately, I know it's long and it's like, you know, like complicated in terms of you have to like plug in a lot of numbers into the calculators to figure out whether it's a positive or negative inside the table, but it's the only way that we have, at least for me, to define like the maximum and minimum in an easy way. Okay, there are actually like many more ways, but then for this class, let's stick with the table of signs. Okay, so first of all, let me find the domain of f first, and as you notice, this function in here is actually a polynomial, right? Which means that like it's defined everywhere, right? Like no matter what value for x that you plug in here, it always gonna make sense, right? We're not gonna have something divided by 0. If you have like x being negative in there, it's gonna give you a number. If x equal to 0, it's gonna give you a number. If x is like some positive number, it's also gonna give you a number, right? Like there's no x value such that like when you plug into f, it's gonna make the function undefined, right? So that means that the domain in here, d of f, is all real number, I would say r. Okay, and next step, like usual, we're gonna take the first derivative of it. So f prime of x in here, I'm gonna do it really quick in here. So 6 times 2/3, that is 12 divided by 3, and then that's 4. So we have like a 4 in here, and then this one minus 1, so it's like what, negative a third. And then for the second one, we're gonna have like a minus 4 in here. Okay, and if you want, you can rewrite them. Okay, so I noticed there's a 4 in common, so I'm gonna put the 4 out front first. Okay, and then at the same time, I'm gonna rewrite the x to the negative 1/3 by putting like 1 over x to the 1/3, but then 1/3 in here means like the q root, right? So let me just put q root in here for x 3, and then minus 1, okay, for like, because we factor out the 4 already for the second term. Okay, and now I'm gonna have to put them as the same fraction. So how can I do that? Well, 1 is actually 1 over 1, right? So I'm gonna multiply the top and the bottom for the second fraction by q root of x, and then that gives me something like the 4 is out front, and then on the inside I'm gonna get 1 minus q root of x divided by q root of x. Okay, so this one is just, it's more like algebra, but if you have any questions, just let me know before you like continue to watch the video. Okay, so we're gonna have like the top part in here and also the bottom part in here. So this is top and this is like the bottom. We set each of them equal to 0. For the bottom is easier, for me at least. When you set the bottom, this one equal to 0, you're gonna get x equal to 0. The top part, if you set this whole thing equal to 0, in short, you're gonna get x equal to 1. Okay, and again, it's more like algebra, so if you have any questions on these, let me know. Okay, like make sure you let me know in the video, because I'm just focused on the concept in here, not so much on the, you know, like algebra. That's why I like skip forward all the way to, you know, like the final process. But again, if you have any questions, just let me know. Okay, So let me color them. So for the bottom, I'm gonna have x equal to 0, and then for the top part, I'm gonna have x equal to 1, and they all are my like critical numbers, right? So by the table of sign method, I'm gonna create like a table, like a small table for me in here. The first line here is the x part, and then the second line is the top part, which is 1 minus q root of x. And then the next line is the bottom, which is q root of x, and then the last line is, you know, like the derivative, right? So we're gonna get like the f prime of x. Okay, so I told you for the x value is gonna go from negative infinity all the way to positive infinity, and then in there we're gonna have some like critical numbers in here, and we have to arrange them from least to greatest. So 0 is the smaller one, and then 1 is the bigger one. Okay, and then let me put like the in blue for the 0 on the top part. So I'm gonna have a 0 in here, right? And then I'm gonna have the 0 onto the bottom at 1. Wait, I feel like there's something weird. Hold up. So the 0, it should be at here actually for the bottom. And for the top part, it should be at 1 right here. Okay? And then for the outer space, I'm gonna put like a number in here, or you can just like slash it, or you know, like put a dash in here. I don't like really care what you put in here, but remember, if you put like a dash in here, don't get confused with the negative signs, right? Because you know, like later on we have to fill in the positive and negative sign here, like plus and minus. So I would not recommend doing the dash in here. Rather, you can just put like the number or just slash, right? So for me personally, because I know it's gonna be a number, so I'm just gonna use the number symbol for that. Okay. And then for the f prime in here, because this one is the top part and this one is the bottom part, so then for this place in here, we're gonna get the number divided by 0, which is undefined, or like d and e. For the outer place, I'm gonna get 0 divided by a number, which is 0. Okay, so this one is pretty much just like the last thing that we did in 3.1, right? Like nothing changed too much. So I'm gonna go ahead and skip the procedure for this one, and then let me put like the check number, or like the plug-in numbers in here real quick. So for me, I'm gonna use like -1 for here, and then maybe like 0.1 for here, and I'm gonna like 2 in here. And with that, I'm gonna get the table of sign, which is a positive in here, minus in here, and then plus in here, and also minus and plus in here. Okay, and make sure you check this one to understand why you have like those plus and minuses. Okay, and then lastly, for this spot in here, top divided by bottom, so I get a positive number divided by a negative number, that is negative. And for here, I have positive divided by positive, so that is positive. For here, negative divided by positive, I have a negative. Okay, so now like this is like the end for like the last problem, right? But unfortunately, this one is not like asking for the increasing and decreasing interval. Is asking us to find the relative extrema, right? And I told you guys that we have like 2 critical numbers in here, so it could be like either the maximum or the minimum in here, right? So how do we know if it's a maximum or minimum, right? So now let me draw the shape of it, right? So this one is negative, so it's going down like this, and this one is positive, so it's going up and then down, right? So right here, right? Here, let me just put this one in here. Let me use pink for this one because I want to highlight that out. As you can see, like in here is the lowest point, so it's gonna be a minimum, and in here it's gonna be a maximum, right? Because it's like it's like the top of a mountain, and then the other one is like the trout of the valley. Okay, and then lastly, here, let me connect it to, you know, like toward the table in here. So this is the new part from the table, right? Like this is like the shape of it. I'm gonna like put shape in here, or should I say, okay, let me put it in a nicer way. How about this? I'm gonna put relative extremum. Okay, and then we're gonna know which one is max and which one is min, right? And in the test, I would really appreciate it if you just put like, you know, like this in there. Okay, and then for the last box in here, you have to calculate the value of them, because it's not like good enough if we only have the x value, right? We also have to get the y value. So what we're gonna do is that for 0, we're gonna plug in 0 into the original function. So let me get some space in here. So let me put 0 in blue, because it's for like the top part. If I plug in 0 for this one, if x equal to 0, then I'm gonna get 6 and then 0 times 2/3 and then minus 4 times 0. Put all that into the calculator, I'm gonna get a 0, right? So in here, I'm gonna have a 0, like underneath of the x equal to 0, okay? And now we're gonna do the same thing but for 1, and since 1 is the one from the like the bottom in here, if I plug it into this original function, I'm gonna get 6 times 1 to the 2/3 and then minus 4 times 1. And if you put all that into the calculator, it's gonna give you a 2, and then underneath of the 2 on the last box, you're gonna put a 2 in there, okay? So now let me get rid of this error in here, and this is like the complete table that I want you to show in there. So make sure that you guys have to include like the last 2 boxes in here. Like this one is a new thing, right? Like we didn't learn it from 3.1, but then we have to include it in 3.2, so make sure you have them, okay? So as like the final part for the conclusion in here, make sure you write something for me to know that which one is relative max and which one is relative min, right? So as for like the big conclusion in here, let me just put them in, I don't know, like brow. Okay, so relative min, as a point, I'm gonna get, okay, we know that this is a min, right? This is the x value, this is the y value, so it equals to 0, 0. Okay, and then for the relative max, we know that this is the max, the x value is 1 and the y value is 2, so putting them together, we're gonna get 1, 2. And this is it, okay? So all the thing in red is like, and blue and green are like the work that I'm expecting to see in the exam and in the quizzes. And then the brow things in here, like the brow, the work in brow in here is to find the answer, okay? And if you want to like double check it with the work in here, well, if you want to double check your work with the graph in here, that's why I also put the graph in here so that you guys can check your work, right? So let me take some of these work out first so that you can see the graph. Okay, so look at this graph in here. You will see right away that we have like, this one is the lowest point, right? I mean like this one, it keeps going further, right? But at least for this interval, like it has some stopping point. So this one is like a relative min, and this one in here is like the relative max within that interval, right? And again, like max and min in here is really relative compared to like the interval that you're talking about, because as you can see in this like graph in here, apparently like there's no like maximum, there's no absolute maximum, right? Because this function keeps like reaching like higher and higher up, and then it keeps reaching like lower and lower. So there's no like absolute max and there's no absolute min, but there's a relative max in terms of, you know, like at some points going to be like higher than some, just some values, and at some other like points it's going to be like lower than at least some values in your function, okay? And this is like the work that we had in here. So 0, 0 for the min, and then 1, 2 for the max, okay? So if you notice on your question on your part, and let me put a green star for your part before I forget to do so. So this is what you have to do. And if you notice, you're going to have a relative max in here, right? Like I'm not going to tell you guys the value. This one is a relative max. If you do the right job, you will see that it's like slightly bigger than 2 and it's slightly like greater than 8 in here for as a point. And it doesn't have any min, right? Like this one is a flat point, right? It's just like it doesn't have any min. So for your answer, you should have just one relative max. And then for relative min, you're gonna say none, okay? And that's like an okay thing to happen, right? Like we don't have to always have the relative max and relative min. Sometimes you're not gonna even have any relative max or min. Sometimes you're gonna get like 2 relative max and then, I don't know, like no relative min. Or some other time you're gonna get like 4 relative maxes and then just, you know, like 1 relative min. Like anything could happen for this case, okay? Let's move on to objective 2 in here, absolute extrema. So I just mentioned the word absolute max and absolute min earlier, if you know this. Absolute in here is like you consider the whole domain of your function, okay? And usually that domain, that restricted domain will be given by the problem. That would give you like a certain like intervals for you guys to consider, like the absolute max and absolute min, okay? And then the things will just be, you know, like similar to what we had in here. So the absolute max in here would be the highest point compared to all the other points in your graph, and then the absolute min would be the lowest point compared to, you know, like all the other values on your graph, okay? And then just a little bit heads up in terms of, you know, like terminologies in here. The terms relative minimum and relative maximum describe the local behavior of the function to describe the global behavior of the function on the entire interval. You can use terms absolute max and absolute min, okay? So just to like, you know, like make it like clear in here, relative is referred to, you know, local, and then absolute, it refers to global, okay? And again, I'm not gonna test you too much on the like you know, like the terms in here, so don't worry. A lot of you, if you like get confused for like local and global, because it's just, you know, an English issue, and I'm not gonna judge you too much on that one, okay? All right, so the absolute minimum and absolute maximum values of a function in an interval are sometimes simply called the minimum or maximum, okay? So if it just like maximum and minimum, you have to understand that it's like the absolute maximum and absolute minimum, okay? Else they're gonna say relative maximum and relative minimum, okay? And a point can be both relative and absolute minimum sometimes, okay? And I'm gonna show you like 4 examples in a second to see that sometimes they can repeat, right? Like right now we have like 4 concepts, right? Relative maximum, relative minimum, absolute maximum, and absolute minimum, right? Some of them can repeat with the other ones, and that's fine. That's like totally normal, okay? Now let's talk about the extreme value theorem. If f is continuous on the closed interval AB, then f has both a minimum and a maximum on AB. You will see why in a second, where for like a closed interval, like if you notice this one is a closed interval, right? So like that will cut out like all the, you know, like keep going part of the graph, and then that will terminate like the graph on 2 sides, and then we always gonna get an absolute minimum and an absolute maximum, okay? Although a continuous function has just one minimum and one maximum value on the closed interval, either of these values can occur more than one x value, okay? I'm gonna show you guys what it means in a second. And okay, so just like a little bit of, you know, like warm up before we talk about example 2. So my question in here is like, label each point as a relative maximum R min, relative minimum R max, absolute maximum or just min in here, or like A min, or absolute maximum A max, or just max in here, okay? And in the test, you don't have to write out everything in here, so you can use like R min, R max to refer them to, you know, like relative minimum and relative maximum. And I'm okay with that, okay? So let's talk about the 4 examples that I have for you guys. Okay, so we know that we have to label each of the point as, you know, like one of the 4 like notations in here, right? So this point here, because it's like the lowest point in the red curve, right? So I'm gonna say that this is an absolute minimum. So this is like A min, or okay, I'm gonna do like AM for short, okay? And then this one in here is like higher than like other points at some points, but it's not the highest value, right? So I'm gonna call this one a relative max. This one in here is lower than some other values at some points, but it's not like the lowest value. That's why it's gonna be a relative min. So let me just put like R min in here. Okay, let's be more clear about this one, to put like R max, and this one is like A min. Okay, and lastly, this one in here is the highest point, right? So it's gonna be A max. Okay, for the second picture, let me put it in pink so that it doesn't get like confused with others. This point here is the highest point of all, so it's gonna be A max. The outer one is gonna be A min in here because it's the lowest point. And then we don't have like any like relative max or relative min, right? Because we don't have like any like loop in there. Okay, and what do I mean by loop? I mean like this. Let me put it in like blue. I don't know. If you have a U shape in here, right, that means that you're gonna have either a relative maximum or a relative minimum, okay? For absolute max and absolute min, it's just like a really, like literally the highest point and the lowest point compared to like everything else in your graph, okay? But the U shapes in here, they refer to the relative extremum, okay? And then let me get back to red for the third picture. So in here, I'm gonna get this one equals to my absolute max. Okay, this one and this one, they at the same value of y equals to -2. That means they are both the like the, what is it, the absolute min. So let me put a min in here and also a min in here. So this is what I mean by, you know, like it's just gonna have like one minimum and one maximum, but then sometimes it can occurs more than one x value. Okay, so in here the value of the minimum in here, the value of it is equals to -2, but then it occurs at x equals to -2 and also at x equals to 1. Okay, so this is what I mean by like this like scarce sentence in here. Okay, and what else? This one in here is a loop, so this is relative maximum. And if you notice, not only that one has a loop, right? Like the other one also have a loop in there, right? So this one is also a relative minimum. And I told you guys it's okay to repeat them like sometimes, right? So for this point right here, it is a absolute minimum and it's also a relative minimum, and that's totally fine. Okay? And then let's talk about the last picture. Let me put it back in pink. This one, as you all can tell, this is the absolute maximum. And same goes for the other one because they both are on the same level and they both are like the highest value among like the red curve in here. Okay, and then we have like 3 more points in here. So this one to me is the absolute min, and if you guys notice, it's also have a loop in there, so it's also a relative min, right? And for this one in here, it has a loop, like it's going like it looks like an upside down U, right? So to me, that relative max. And this one in here, if you notice, if you like zoom the picture like in a little bit, it's a U shape, and that's why it's a relative min. Okay, and let me circle this one to show you guys that it can be like, you know, like one point can have 2 names. Okay, and again, if you have any questions on this one, let me know. Okay, so this one is all about like labeling, right? Like just for us, you know, that one point can have more than one name, and then one maximum value or minimum value can repeat for like multiple values for x. Okay, and if you must like see the loop in here, let me just show you guys the loop in here really quick to convince you guys that it's gonna go that way. Okay, and now let's talk about my example. So for my example, I have to find the minimum and the maximum values for the function. Okay, so just like before, we're gonna have to find the domain first, and then after that, we're gonna take the first derivative, and then set the top equal to 0, the bottom equal to 0, and then, you know, just set up like the table. But for this one, because we're looking for the values only, right? We're not gonna look for the relative maximum and relative minimum anymore. So it will be easier a little bit. You don't have to go through like, you know, the table of size. We're gonna have a table, but we're gonna have a table of value, and let me show you guys what it means. So let me put that back in red. So this one is just like the same function that we have from before, so let me do it really quick in here. The domain in here of f equals to all real numbers or just r, and then the derivative of f. If I just copy and paste from the last like work, I'm gonna have a 4 in front, and I'm gonna get like 1 minus q root of x on the top part, and then q root of x also for the bottom part, right? And then for the top part, I'm gonna get x equal to 0, which is the first critical number. The second, like the bottom, for the second critical number, I'm gonna have the bottom equal to 0, and that gives me x equal to 0. Okay, and now let's talk about the table. And I told you guys, because this question is asking us for the minimum and maximum values, right? So we have to focus on the values. And what does it mean by values? Well, we're just gonna plug all the x's into the original functions to get the values, and that's all we do. Okay, we don't have to go through the table of size anymore. Okay, so now just confirm what we have so far in here. We have the critical numbers. The critical numbers are 0 and 1 from before. Okay, and then we also have the endpoints, which are given from the problem. The endpoints are, what is it, -1 and 4, right? So we have -1 and 4. Okay, so how many x's do we have in here? We have 2 x's from the critical numbers, and we have like 2 more x's from the endpoints, right? So in total, we're gonna get like 4 x's, okay? So what we're gonna do in here is that, well, okay, so this one you can either use a table, or if you don't want to, if you want to be like casual, you can just, you know, shove all of the x values in here into the original function, which is this one in here, and then we're gonna like compare them, okay? So let's do it really quick in here. F of, okay, which one is the smallest in here? We have -1 going first, and after that we also have to find f of 0, and then f of 1, and then f of 4, right? And really quick, these numbers coming from either the critical values or the endpoints, okay? Like it's all about like these numbers that we have from earlier, okay? And we're gonna go ahead and shove all of them inside the first like original function in here. And for each time, we're gonna get a value. So let me do it really quick. Okay, if we put like -1 in there, we're gonna get like 6 times -1 to the 2/3, and then -4 times -1. That gives me a, what is it, a 10. Okay, for 0, as we did it already, but let me just like copy it really quick in here. So -4 and then 0, that gives me a 0. We're gonna do the same thing for 1, so it's like 1 in here. 2/3, and then -4 times 1, that gives me a 2. And lastly, if I put in a 4 in here, that gives me a decimal -0.88. Okay, so let me highlight all the finalists that we have in here, all the like final values. So we have 10, 0, 2, and -0.88, right? So now you have to ask yourself, like, which one is the biggest and which one is the smallest number in here, okay? So let me put it in, I don't know, blue. Okay, so the maximum in here is 10, right? Like, that's the maximum value. And then the smallest value in here is -0.88, right? So as for the conclusion in here, I'm going to put it in blue again. So absolute min, or I'm going to say just min in here because they're the same thing. It is at, what is it? Where's the min? 4 and comma -0.88. And this one should be a comma for this one, okay? And then we're going to do the same thing for like the max one in here. It's going to be, or max in here equals to, where is it? -1 and 10, okay? And remember one thing, there's only one value for max and min, right? But then there could be more than one x value. So you could have like more than 1 point, okay? Like for these, one value for y, but then more than 1 point, okay? And this is the final answer, so let me just box it before I move on really quick in here. And if you want to compare to the graph that I already have for you guys, let me take out some work in here so that we can see the graph. Okay, so as you look at the graph in here, let me put it back in red. So the highest point among everything in here is like the value of 10 at x equal to -1, right? This one is our max. That is correct, right? And then the lowest value in here is this one right here at x equal to 4, and we have the value of it equals to -0.88, okay? So this is like the x part is for like where it happens, okay? Like x part is for where, and then the y part is for the value, okay? So make sure you know like what the question asks you to do. For this one, it's only asking you about a value. So actually, if you like answer me like the absolute max in here equals to like 10, and the absolute min in here equals to -0.88, I'm like cool with it too, but I just want to be fancy and make it like a point, okay? So if you can put them as a point in the test and in the quizzes, that will be like, you know, like highly appreciated by me, okay? And let me put a green star for your part before we move on. Okay, so now let's talk about applications. Finding the minimum and maximum values of a function is one of the most common applications of calculus. Okay, so let me put a green star in here before I forget again. So this is what you have to do. And for my part, the quantity demanded x for a product is inversely proportional to the cube of the price p for p is greater than 1, and when the price is only like $10 per unit, the quantity is demanded the quantity demanded is 8 units. The initial cost is $100 and the cost per unit is $4. What price will yield a maximum profit? Okay, so this one is a word problem, right? And then as you can see in your problem, you don't have to like derive a formula in here because it's just given. For my example, I want to make it hard so we can, you know, like get a taste of how hard it could be, right? So all right, let me just do it really quick in here. But trust me, like I'm not gonna give you something as like this hard in the assessment, so you don't have to worry too much about it. Okay, so what does it mean to be like inversely proportional, right? And then cube in here. So let me go from the top in here. We start with x. Okay, and then inversely, it means we're gonna flip them, so we're gonna have a 1 on top, or like the k on top, the k in here for the proportion. Inversely, for, you know, like the thing that it will mention in the next sentence will be on the bottom. So we have the cube of p, which is like p cubed in here. Okay, so let me just use the color code really quick for this. So k in here is for proportional, and then for the other one, let me put it in green. The q of p inversely, that means that everything in here has to be on the bottom. Okay, all right, so what do we do is that, well, we notice that when the price p equals to 10, then the quantity x equals to 8, right? So what does it do? It means that when p equals to 10, so k is unknown, right? But then when p equals to 10 in here, then x equal to 8. Okay, like this is from like what is given, right? So from there, we're gonna try to solve for k in here. And how do we do that? Well, we're gonna do something called cross multiplication, and a is a over 1, right? So we're gonna do like this cross equals to that cross. So that gives me k times 1, which is k, and then for the outer cross, if you put everything into the calculator, you're gonna get 8,000. Okay, so in shortcut, like if you put it back to like this formula right here, you're gonna get the new formula, x equals to 8,000 divided by p cubed. Okay, so now what do we do, right? Well, we have to find the revenue function first in here, and then from the revenue, we need to get, oh wait, okay, so what the question asks us, right? Like it's asking us for the profit function, or like to maximize the profit function, right? And in order to find the profit, let me just remind you guys of a quick formula, that p equals to revenue minus cost. So if we have the price function, we can get the revenue function, because revenue equals x times p, where p is the price function. And then the cost function, it is given in the problem where it says the initial cost in here is 100, and then the cost per unit in here is $4. So just by the word per in here, it means that the 4 will be attached to an x, and then initial cost, it means just that, you know, like the money that you have to pay like that one time, right? So the c function, it equals to 4x plus 100. Okay, so that's the easy part, right? But then how can we figure out like the revenue function? So let me take out like some of these work really quick in here. Okay, now that we figure out the relationship between x and p already, we're gonna get the revenue function by doing x times p. So revenue, it equals to xp, and then what is that gives me, right? So I'm gonna do, well, if you notice, x in here, okay, let me put it in blue, maybe x in here, it equals to like this function, right? So I'm gonna go ahead and replace that by x. So let me put it in blue again in here. So x in here is equals to 8,000 divided by p cubed, and I multiply it by the outer p. So 1 of this p will cancel with 1 of this p, and then it gives me a square in here, right? So in short, it equals to 8,000 divided by p squared. Okay, so I have the revenue function from here, I have the cost function from here. For the profit, I'm gonna take the revenue minus the cost function. And how does that like work, right? Like what does it do? Well, we're gonna do r in here, which is 8,000. Okay, this is p for the profit. 8,000 divided by p squared. minus cost, which is 4x plus 100. But wait, there's something wrong with this one. Why is it wrong? Well, we have a p in here and we also have an x in here, which is like weird, right? So let's not do it like that, okay? Like, let's not do it like that. Okay, so now it's the time that you have to figure out whether you should go with x or p, right? And then look back at the question in here because it's asking you what price will yield the profit. So that means that we have to solve for p in terms of p. Okay, so the big P is for the profit and then the small p is for the price. Okay, so that means that we have to get rid of x and somehow replace that x with p. And well, what do we know? We know that x equal to 8,000 divided by p cubed, right? So instead of having this x in here, we're gonna replace it by 8,000 divided by p cubed. Okay, so let me put it really quick in here. Take this away. Okay, so this equal to 8,000 divided by p squared. Just rewrite as a rounding function. But for the inside now, instead of having the x, I'm gonna get the 4 in here, and then 8,000 p cubed, and then plus 100. Okay, and in here, if you multiply 4 with 8,000, you're gonna get 32. So let me do it really quick by just like fixing the number in here. So 8 times 4, you're gonna get a 32 in here. Okay. And then now what we're going to do is that we're going to have to break out the parentheses. So I'm going to distribute a negative into the first term and also into the second term. Okay. So at the end, what do I get? I have 8,000 over p squared and then minus 32,000 over p cubed and then minus 100. All right. So now next step, let me take the derivative of everything, right? Because when it comes to the word maximum or like minimum in here from the problem, you know that you have to take the derivative, okay? And if you think about it, like this chapter is all about the derivative, right? That's why we learn all the like quick ways, all the rules to find the derivative. Okay, so let me put it in pink. Okay, p prime. What does it equal to? Well, if you know this, like this one will go down to 0 because it's just like a number, right? And before we take the derivative, actually, let me just go back and rewrite the p function in terms of, like power function, because it will be easier for us to take the derivative of them that way. So this equal to like 8,000 and then p to the negative 2 and then minus 32,000 and then p to the negative 3 and then minus 100. Okay, and then p prime. Profit, this will go down to 0, and then in short this is negative 16,000 and then p to the negative 3, and then this is a positive 96,000 and then p to the negative 4, right? And then after that you're gonna set this thing equal to 0. Well, because we have to like maximize it, so to find the critical numbers we have to set the derivative equal to like 0 or undefined, right? But in real life application, the word undefined is kind of like like weird. It doesn't make too much sense for the word undefined. That's why we always gonna go for the case of the derivative equal to 0. Okay, so I'm boxing this one in here because it's like the step to find the critical number, okay, but it's not the final like answer. Okay, so we go ahead and do that, and if we set it equal to 0 in here, you're gonna get p equal to 6. Okay, as for the procedure, if you insist how I solved it, okay, let me just like slow down a little bit and then show you guys the logic behind like why the price equal to 6. Okay, so okay, first of all, let me just rewrite them. So it's gonna look like negative 16,000 in here, and then p cubed, and then plus 96,000 and then over p4, right? Like, so we all good with this, right? It's just like rewriting the power, right? And after that, I'm gonna try to factor out as much as I can. So I'm gonna factor out like a PQ on the bottom, and on the top part, well, definitely I'm gonna factor out 1,000, right? But if you notice, we can also go out for another 4, right? Like, so we can go for like 4,000, right? So for the inside, we're gonna get negative 4 for the first term, and then we're gonna get, what is it? Let me grab my calculator really quick. So 96,000 divided by 4,000, it equals to 24. Oh, actually, you know what? We can factor out like the whole 16, right? So let me go ahead and fix that into a 16 instead, because that's going to be like smaller, easier for us to do. So I'm going to factor out 16,000 from beginning. So in here it's left with -1. That's my 1. And then for the inside, I'm going to get 96,000 divided by 16,000. That is 6. And now on the bottom, I'm just going to get just 1p, right? Because there's like 4 p's, and then 3 p's go on the outside, so then 1p will stay inside, right? So this equal to 0, right? So we know that this fraction can never ever be equal to 0, because like if we have a number divided by, you know, like anything, it's not going to be ever equal to 0 unless you have the 0 on the top part, right? So that means that we're going to have to set the inside stuff inside the parentheses equal to 0, and that is -1 plus 6 over p equal to 0, and in here you're going to add 1 to both sides, and then that gives me 6 divided by p equals to 1, and then after that 1 equals to 1. 1 equals to like 1 divided by 1, right? So I'm going to do like cross multiplication in here. That gives me p equals 6, and this is the price for it. So this is like the price to maximize the profit, okay? And that's the answer, okay? And if you want to double check like get the answer with the graph in here, let's do it really quick by, you know, like get rid of some of the work in here so that we can actually see the graph. Okay, so if you go ahead and graph the function that you get earlier into GeoGebra or like Desmos in here, you will see that it gives me like a maximum in here, right? Like it's like everything like in the red curve in here has to be lower than that, okay? If you like want to zoom it out, it's gonna look like this. So it's gonna look like this, like a little bumpy. Okay, let me just try it again. Okay, so this is like where the 6 is. It has like a little like loop in there, but then it's just like too small for us to see, but it does have a loop in there, okay? So this is like the highest price that you can get, okay, to maximize like the profit, okay? And let me double check whether I put a green star in your part. Okay, so this is like the right hand side. That's what you have to do to turn it in, okay? And again, if you have any questions, let me know, okay? Thank you for your listening. Take care and have a great day. Bye bye.